We've all seen the Hollywood version of an asteroid strike, right? The movies always show this sudden, chaotic scramble for survival, or they flash back to that prehistoric doom that wiped out the dinosaurs. And honestly, those portrayals do a great job hooking us into the sheer apocalyptic terror of a cosmic threat. But how would a real asteroid threat actually play out in the modern world? Welcome to This Explainer. Today, we're going to separate the Hollywood myth from scientific reality by looking at the official findings of a recent, highly detailed government simulation. So, let's just dive right into this. What if, instead of just 24 hours of frantic scrambling like in the movies, you were given exactly 14 years to stop the apocalypse? Well, that's the core question posed by a recent, incredibly detailed NASA tabletop exercise. In this explainer, we're pivoting away from those sudden dramatic disasters of the silver screen, and we're looking at the very real, kind of grueling 14-year countdown of a genuine planetary defense scenario. And as you'll see, it completely changes how we have to think about global survival. Okay, Section 1, NASA's 14-year warning. To really understand our real-world readiness, we're going to unpack the official after-action report from NASA's Planetary Defense Interagency Tabletop Exercise 5. They call it PDTTX-5 for short. This whole fascinating simulation took place over 2 days in April 2024 at the Johns Hopkins Applied Physics Laboratory. And listen, this wasn't just a bunch of astronomers peering through telescopes. This simulation was a massive, joint effort that heavily relied on interagency collaboration. We had NASA handling the space side, FEMA handling the disaster response on the ground, working right alongside the U.S. Department of State and international partners like the European Space Agency and the United Nations. Basically, everyone gathered to test our real-world readiness for a truly global threat. During the exercise, the teams had to deal with a terrifying simulated impact damage corridor. They mapped out a potential strike zone stretching all the way across the United States, over the Atlantic Ocean, and straight through Africa. But here's the catch. The margin of error was absolutely massive. During the simulation, the asteroid's actual size, its impact energy, and the potential damage it could cause were highly uncertain. The participants were told an impact could happen in 14 years, but there would be an immediate 7-month blackout period where they couldn't even observe the asteroid because it would be hidden by the sun's glare. So they had to start making massive decisions based on huge, terrifying unknowns. That brings us to a crucial takeaway. Real planetary defense is a grueling 14-year waiting game, not a sudden 24-hour dash. Just think about this timeline. In year 1, the asteroid is discovered, but you immediately hit that 7-month observation blackout. By year 5, 5 whole years later, you're only just launching potential reconnaissance missions just to get a closer look at the rock. Fast forward to year 10, you finally launch the actual missions meant to prevent the impact. And then, year 14 is the potential impact date. The entire exercise really forced the participants to realize that managing this massive uncertainty over more than a decade is the true challenge of planetary defense. Moving on to Section 2, Stopping the Impact. So, once we know a threat is out there, the first major objective is obviously stopping it before it hits Earth in the first place. But here's a sobering fact. Currently, only one Earth impact prevention technology has ever been demonstrated in flight, and that is kinetic impact. The report specifically highlights that while NASA's recent DART mission proved we absolutely can successfully nudge an asteroid by crashing a spacecraft into it at high speed, we've only actually tested it exactly once. We completely lack proven, flight-tested capabilities for using multiple impactors or other theoretical methods like a gravity tractor or ion beam techniques. If a massive rock is headed our way right now, we're banking almost entirely on a technology that's honestly still in its infancy. Because of that lack of tested tech, the exercise identified some major gaps. And honestly, when it comes to space missions, simple bureaucracy is a massive hurdle. Funding and launching a rapid reconnaissance spacecraft to go look at the asteroid is currently hindered by a total lack of clear decision-making processes. The report highly recommended that we deeply need to codify what they call go, no-go criteria. Right now, the timeline for making those high-stakes decisions is incredibly unclear. We need established risk tolerance guidelines so that politicians and space agencies know exactly when to pull the trigger on funding a mission to save the planet. Which brings us to Section 3, Preparing for Ground Zero. What happens if the space mission fails? Or what if we just can't launch in time? Well, then we have to shift our entire focus to the ground. And sustaining emergency preparedness down here over a 14-year period is incredibly difficult. A decade and a half vastly complicates your planning. You're inevitably going to face warning fatigue among the public. People are simply going to stop paying attention after a few years. You'll face changes in political leadership across the globe, wildly fluctuating budget cycles, and changing personnel at critical agencies. Furthermore, the simulation revealed a stark lack of specific near-Earth object disaster plans. Responders would essentially have to figure out how to adapt existing disaster protocols for something entirely unprecedented. And here's a really specific, kind of surprising domestic gap identified in the report. The domestic science community lacks awareness of the National Incident Management System, or NIMS. Now, this is a big deal. Basically, the scientists who study these asteroids and track their orbits, and the emergency managers who run disaster zones on the ground, operate with entirely different frameworks and languages. If an asteroid is coming, these two groups absolutely need seamless integration, and the exercise highlighted that right now, that integration simply isn't there. And the problem gets even bigger on a global scale. Check out this quote straight from the findings. There is no analog to the International Asteroid Warning Network, or SMPAG, for international disaster preparedness for an NEO impact. While our space agencies have great international networks to coordinate looking through telescopes and planning space missions, there is absolutely no centralized UN body specifically tasked with handling the actual on-the-ground disaster of an asteroid strike. It's a pretty alarming gap in our global readiness that leaves any ground response highly fractured. All right, Section 4. Managing global panic. Because, let's be real, it's not enough to just prep spacecraft and set up FEMA tents. We have to control the narrative. In the TTX-5 war room, experts had to grapple with the sheer overwhelming complexity of public information messaging. Picture being in that room, trying to manage the intertwined timelines of space mission launches, ground evacuation prep, and the relentless 24/7 breaking news cycle, all while the public demands concrete answers that the scientists simply do not have yet. It's a communications nightmare. To keep everyone from completely losing it, the exercise outlined several crucial recommendations. The most urgent need is to develop pre-approved holding statements for various warning scenarios before a crisis actually hits. If an asteroid is spotted, space agencies need to address misinformation immediately. They need to coordinate international messaging, utilize existing UN mechanisms, and even leverage harmless asteroid close approaches to practice how they talk to the public. They simply cannot afford to be making up their public relations strategy on the fly during a potential apocalypse. It all really boils down to this ultimate communication dilemma, the threat versus the information flow. The scientific reality of the threat is a slow, agonizingly long 14-year trickle of highly uncertain orbit and size data. But the information flow, that's an instant explosion of global speculation, deliberate disinformation, and a ravenous demand for concrete answers on social media. Contrasting the slow scientific process with the rapid, unyielding pace of internet panic was noted as a major, major challenge in the TTX-5 report. And finally, Section 5. Are we really right? So after facing down all these terrifying space mission gaps, the disaster prep hurdles, and the nightmare of public panic, what was the final takeaway from the participants themselves? Surprisingly, despite exposing all these gaps and bureaucratic nightmares throughout the simulation, an overwhelming 91% of the participants actually left the exercise feeling better prepared to deal with the capabilities and challenges of an asteroid impact threat. Facing the nightmare scenario head-on and carefully stepping through those intertwined timelines genuinely equipped them to handle the realities of planetary defense. But to actually turn this tabletop theory into real-world readiness, the report laid out some urgent homework. Up in space, we absolutely must define those go-no-go criteria and figure out how to rapidly repurpose spacecraft. Down on the ground, the UN desperately needs to establish an international planning forum. We need crisis communication templates locked in, And from a legal standpoint, we even have to figure out the policies for using nuclear explosive devices in space. NASA, FEMA, and their international partners have a lot of very specific homework to do. All of this really leaves us with one massive, vital question. Is 14 years enough time to unite the globe against an apocalyptic threat? We have the technology to spot the threat, and we might even have the technology to stop it. But this exercise proved that the real hurdle is the fragility of human coordination. Can our politics, our budgets, and our very short public attention spans hold together long enough to prevent the ultimate cosmic what if? It's a pretty profound question we all need to ponder. Thank you so much for joining me on this explainer.